Good afternoon, everyone. We're going to go ahead and get started. So my name is Ken Gilbert. I'm a solutions consultant with Augmented Logic Corporation. I'm also a volunteer on the BACnet International Marketing Committee. And so today we're going to talk about BACnet and mission critical facilities. And so some of the things that we're going to talk about today is I do want to just give a brief history of BACnet, which is pretty significant because we're celebrating 30 years of BACnet. And I would encourage each of you to go to the BACnet Institute. There was a panel session and discussion yesterday that really talked about the history of BACnet that is beneficial and is interesting to see. Then we're going to talk about why BACnet is an acceptable protocol in mission-critical applications and how BACnet can monitor and control data centers, how you can use BACnet in lab environments, and then how BACnet is used to address gigafarm challenges. All three of these being mission-critical type of environments. So with that, we're going to get started. So the year was 1987. And I do see a few people in here with gray hair. So I was a junior in college. So Full Metal Jacket, that was the movie of the year. How many of you remember Bon Jovi, Living on a Prayer? That was one of the songs of the year. And then one big significant economic event happened in 1987. Black Monday, the stock market crashed. I can still remember being in college going, oh no, we're going to be graduating in 2 years and we're not going to have jobs. But one of the really interesting things that was happening in 1987 as well is in Nashville, Tennessee, the development of the BACnet protocol started. It was the first meeting, the inaugural meeting of the AHR BACnet Committee, SSPC 135, and its main objective was to create a protocol that would allow interoperability between various manufacturers. So what ended up happening is in August of 91, so this is just a few years later, the first public review draft was published for comments, and it generated 507 comments from 6 different countries. So this wasn't just something that happened here in North America or in the country, it was globally. Then a second revised version of the draft was published in March of 1994 and generated 228 comments across 12 countries. So once again, there was more global involvement in this. Then the third and final version was published in March of 1995. And this third review generated, guess how many comments? 6. That's a big deal for AHR. I only have 6 comments. So the final version was approved and became a publication as a standard in June of 1995. And then just a few months later, it became ANSI national standard, ANSI standard in 1995 in December. So it was originally founded under the auspices of the American of AHR and has continued to live under the direction and guidance of AHR and has always been evolving. So one of the things that's really interesting and fascinating to look, and this is really what I think really highlights the strength and why BACnet is such an incredible and resilient protocol. So if you look here on the left, these are just various things that have happened within the BACnet standard and how it has evolved over the years. And then over to the right are some of the things that we've seen happen in the technology or the IT world. And one of the things that I really want you to take away from this talk is the great thing about BACnet is it has not been a stagnant standard or a stagnant protocol. It has been evolving and changing as technology has been evolving and changing as well. So it really is a good tool to help set you up for the future if you're thinking about future-proofing or what are some things that I can do to be prepared for the future and changes that are going to occur. So when we look at the early days, we had these old computers and these old little controllers. And then we migrated into what we would call web, that's on the right-hand side of the screen there. And all of this was handled through the use of the BACnet protocol. So we had digital and analog outputs and inputs coming into the controllers. The controllers were networked together and used the BACnet protocol to get that information across the network into a front end. So now let's take a minute and talk about why BACnet for mission-critical applications. So we're going to take a few minutes to talk a little bit about some of the features of BACnet that I think make it a robust protocol and something that would be useful for mission-critical applications. So the first thing is, it's both an ISO and an ANSI standard for interoperability between cooperating building automation devices. And as we have moved into the world of the Internet of Things, when we first started using BACnet, what was it used for? This is the interactive part of the conversation. Used it to control what? HVAC, lights. That was it. And today, what are we doing with building systems? We're controlling lights. We're controlling generators. We're controlling security. We're doing DVR. All of that is happening in today's world, and BACnet is a methodology to accomplish that. So some really fun facts. It's estimated that there are over 25 million installed BACnet devices across more than 25 billion square feet of commercial operating space. Those are some pretty staggering numbers. BACnet International estimates that BACnet has about 70% of the share in building controls around the world. Some basics. BACnet stands for Building Automation and Control Network. In case you ever wonder where did BACnet come from, that's what it stands for. But the protocol itself, it defines several services that are used to communicate between devices. So these services include the who is, I am, who has, I have, which are used for device and object discovery. And then BACnet also includes services such as read property and write property, which are used to share data amongst various devices. Some of the advantages of BACnet are its scalability between cost, performance, and system size. So it can be implemented in a small system, it can be implemented in a large system. Its endorsement and adoption by nearly every major vendor in North America and worldwide. So just about everyone has a BACnet interface. And I can remember a time 15 years ago when you didn't get a BACnet interface with everything. In today's world, you can see just about everyone offer a BACnet interface as an option. The robust internet working, including multiple LAN types, and we'll talk about that in just a second. And then the unrestricted growth and the ability to add new innovation and new features anytime. So when you think about this, we started off with devices and how devices were defined, and it was building controllers. Now we have devices for elevators, lights, and those are easily defined and they're easily to be tested and managed by BACnet. So BACnet defines a protocol optimized for reliable and brief object messaging on a network. And BACnet is an interoperability building block. So it's a good place to start laying the groundwork for that interoperability. So this is going to be the most technical part of the slide. So there's something that is called the Open Systems Interconnection Model, or OSI model. Some people will refer to it as the 7 layers model. This is how IT systems are built today. What the BACnet protocol has done is taken that 7 layers and condensed it to 4 layers. So it consists of 4-layer architecture that is able to make BACnet a non-connection protocol, or UDP, and the need for message segmentation and end-to-end error checking is much less than that of direct connection or connection-based protocols. The overhead for discrete transport layer are not justified, and their functions are delegated up to the application layer. So the benefits of that is it gives us a flexible transport architecture, which makes BACnet conducive for mission-critical applications. So how many are familiar with BACnet MSTP? That's probably the most common one we see. But there's BACnet over ARPANET, BACnet Ethernet. It's not used anymore, but back-to-back, BACnet point-to-point. There's BACnet over long talk, BACnet over Zigbee with the wireless stuff, And probably the two that we're seeing the most now is BACnet IP, which is BACnet that's over the Cat5, Cat6 cable, and BACnet Secure Connect, which is really just a secure data link to help encrypt the BACnet traffic on the BACnet network. And it meets today's IT standards using TLS 1.3 encryption methodologies. So now the fun part. So how can BACnet monitor and control data centers? It's interesting, at least in our world, if you say data center, everyone perks up and listens. That's the growing industry right now, and that's where everyone wants to be involved. So data centers have critical environments that are monitored and controlled by multiple building systems that include HVAC, lighting, power monitoring. And these critical environments in these data centers require a tight level of control as well as resiliency to keep the data centers up and running. Control and monitoring of these environments has become even more challenging as rack densities are rising from an average. This is stunning. It used to be the average was about 8 to 12 kW. Now we're seeing that number exceed 100 kW in a high performance application, or particularly into AI. Many data centers are also implementing something called DSIM. How many of you have heard of DSIM? Anybody? So DSIM is a solution that is used to monitor, measure, and manage control data center utilization, the energy consumption, and the health of physical assets. And these assets include the servers, the racks, the power, and the cooling system. It's not just the environment, but it's a way to bring all of this information together so that data center operators can do planning, see what their utilization is. A common thing that we are asked about is how can we push that CPU capacity so that we're getting the most out of it. And so they'll implement DCM solutions. So the beauty of BACnet is it can provide a communication backbone for integrating all these systems together to meet the stringent environmental concerns, but also pass that information on and up to the users so they can maximize the data center efficiency and usage.